Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to the technical session 6A. Myself, Vishita Sauryan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 7th World Conference on Smart Trends in Systems, Security and Sustainability, WS4 2023, London, UK. The 7th edition of the conference is being organized in a hybrid mode. The physical event was held in London, UK on 21st August 2023, and the virtual event is being held through Zoom today, and it happened yesterday, that is 23rd and 24th August 2023. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for presentation and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair of this session, Professor Monica Rathod, Associate Professor, International School of Informatics and Management, Jaipur, India. Dr. Monica Rathod is currently associated with IIIM as Associated Professor. She has over 15 years of MCA teaching experience and as a research supervisor at Rajasthan Technical University, Kota. Currently, 6 students are pursuing PhD computer science under her supervision. She has more than 20 research papers which have been published in reputed journals. We welcome you, ma'am. I'd like to introduce our next session chair, Professor Muhammad Firoz Mridha, Associate Professor, Department of CS, American International University, Bangladesh. Dr. M.F. Mridha is a senior member of the IEEE and is currently working as an Associate Professor in the Department of Computer Science at American International University, Bangladesh. His research work contributed to the reputed Journal of Scientific Reports, Nature, Knowledge-Based Systems, Artificial Intelligence Review, IEEE Access, Sensors, Cancer and Applied Sciences, etc. His research interests include artificial intelligence, machine learning, deep learning, and natural language processing. Thank you, sir. We welcome you.
Thank you, Ishita.
I'd like to start with the papers now. I'd like to invite author Ener Zakir to present the paper titled Challenges in Building Smart and Sustainable Hybrid Microsystems with Renewable Sources for Powering Individual Residences. Please go ahead.
Hello, thank you very much for introduction, and I'm happy to be a part of this valuable conference. I will share my screen now with your permission. Today I'm going to talk about challenges in building smart and sustainable hybrid microsystems with renewable sources for powering individual residences. We represent Azerbaijan Scientific Research and Design Prospecting Power Engineering Institute. The authors of the presentation is Professor Nariman Rahmanov and myself, PhD researcher Aynur Mahmudova. The purpose of our research is to provide a comprehensive understanding of the challenges of hybrid microsystems with renewable sources for electrical supply of individual residences, and to offer insights for policymakers, investors, and practitioners on how to design, operate, and promote these systems. It describes design of the hybrid system for individual house located in Karabakh region of Azerbaijan Republic, and uses PVC simulation tool to get results and follows with their analysis and discussion. Nowadays, the microsystems designed to be feasible, reliable, efficiently, and eco-friendly. Their successful design need to undergo the assessment of whether a proposed system or project is practical, achievable, and economically viable. It needs to be able to consistently perform its intended function without failures or errors over the specified period of time, and needs to effectively utilize in order to avoid unnecessary consumption, and need to be designed and operated with a focus on minimizing its environmental impact and promoting sustainability. Unfortunately, nowadays, some microsystems are installed with just a quick standard installation guides and just running the standard calculations, quick calculations, and as a result, it gets less feasible and less reliable than it is expected. Here in our research, we would like to highlight the comprehensive approach to each step of the microsystem design. And first, it starts with the assessment of the area. The assessment of the site where we need to install microsystem need to consider several aspects. The land need to be carefully analyzed for its agricultural and occupation point of view, the population density, and the integration with the grid, and the future impact to the climate conditions and the current climatic conditions of the selected regions. For our research, we choose the region of Azerbaijan Republic, and this is the Karabakh region. And the reason for this area selection is that Karabakh region nowadays undergo the huge infrastructure upgrade, and
Can you
most of the
present up?
cities
I'm sorry to disturb you, but your slides aren't changing.
aren't changing. Sorry.
Yes.
I will share again, maybe. Now
Yes,
you
it's
can
all
see.
right now.
Okay, okay, I will continue like this. Okay, the Karabakh region of Azerbaijan Republic consists several cities, and mainly, as you can see from the picture, it consists from it has solar resources, and whereas it has several cities in close to each other, all region has its own population density, agricultural designation, and several factors that impacts the its power supply strategy. When we choose the area, we has done the analysis for all the available resources for each city of the region, and identified that Karabakh region has small geothermal and water sources, and mainly consists mainly has solar and wind power potential. And we have, for the evaluation of solar and wind power potential, we have run GIS methods and collected data for the last 20 calendar years, and identified that to have solar system there is more suitable than other renewable energy sources. After we identify the available resources, we have done the selection process for the technology. While selecting the technology, we have checked for several points like public perceptions and acceptance, compatible with existing infrastructure, regulatory and policy frameworks, and long-term viability. The constraint for Azerbaijan Republic is that nowadays the country is still developing the regulatory and policy frameworks, and this is also impacting our technology selections for the area. After we select the technology, we has gone the load modeling, and this step is required to predict energy usage and maximum load demand. Modeling the energy usage of individual appliances with a household can be complex, as it often requires detailed knowledge of the appliance, power characteristics, usage patterns, and energy efficiency. Once we have done the load modeling, and for this we have used the PVC's typical household model, and after that we have run the configuration selection. We have selected the rooftop standalone system for one of the regions that is selected to be a Jabrail region of Karabakh and Havuslu village. We have selected a typical house with 120 square meters of area, and standalone system completed with battery is selected for this as a configuration. After we selected the typical layout, we did the system component selection, and during the system component selection, we use the angles method to calculate if all PV panels and other components of the system. After calculation, we choose the PVC simulation tool to get the results of the PV output and the main balance, normalized production, and battery state of charge as a result. Here we can see the main result of the system, and based on the calculation, the proposed PV panel's tilt angle is 30 degrees. And in the right side here, you can see the all model parameters that we choose for the designated system. And as you can see from the table, the load demand is fully covered with the selected system, and the solar fraction ratio equals to 1. The performance ratio of the selected system is 81%, taking into account all the losses. And the available solar energy for the area is 3,794 kilowatt hour per year. Used energy is less than produced, and it means that there is excess energy that we can help in future we can integrate to the grid as well. Proposed system has zero missed energy and zero loss of load, showing that the solar energy available for the area is efficiently used. In this slide, you can see the battery state of charge, daily distribution within the year, and you can see here 365 points for each day. And the battery maximum depth of discharge is below than 0.2 for only 2-3 days in February and March, while in all other cases, the battery DOD remains above 0.5, an effective value for its life cycle. The panel dimensions are taken from the technical data sheet and identified to be 11, close to 12 square meters location, which is required to install the PV panel. And since we selected the rooftop panel, the area will be provided for us free of charge. The purpose of running of all these simulations is to show that comprehensive approach, multi-criterial approach to the design of the system can result with more efficient and reliable system. Designing the system correctly comes with own set of challenge, and each of can affect the reliability and efficiency of the system. However, a well-designed standalone system can improve the energy security of individual residences despite these difficulties. This can play a crucial role in mitigating climate change and promoting the environmental sustainability of energy systems. The development of and implementation of hybrid microsystems requires significant technological innovation and research. Our research contributes to the development of more efficient and effective hybrid microsystem and provide valuable insight into the challenges and opportunities associated with the integration of renewable energy sources. While running this research, we also would like to highlight that the standalone systems are not only the future of residential power systems in rural areas, but also essential for the industrial decarbonization. And once they are gone, the comprehensive approach in its calculation and selection, this can be more reliable and efficient. And here I came to the end of my presentation and would like to thank you for your attention.
Thank you. We'll go ahead with the questions.
Yes, I know. I have one question. That have you carried out? Am I audible to all of you?
Yes, I hear you.
Okay. Yes, I know. I just want to ask that have you carried out some literature review also? Literature review.
Literature review. Yes,
Yes,
of course. Yes, and this I believe in our proceedings you can have a look to that literature review as well. Of course, this kind of research are done a lot, but what we have done in our case, we use the area. This area has never been under research previously in the Karabakh region and Jabrail Hovuslu village. And also what is new in our article is that for each step, we have gone the comprehensive approach, not only to the design, but each step of it.
Okay. So actually, you can show the comparative analysis between the existing system and in your model. I have skipped your literature review slide. So that's only a suggestion that you can use the comparative analysis also.
Thank you very much. We will consider this in the future.
Thank you. Thank you.
Sir Mridha, would you like to ask any question?
No. Thank you, Ainul, for your nice presentation. I have no question. Thank you.
Okay.
To you, thanks to you.
Thank you, Ainur. We'll be moving on with our next presentation. I'd like to invite presenter Ashok Kumar Seni to present the paper titled Citrus Fruits Leaves Disease Detection and Classification with Optimized Deep CNN. Please go ahead, sir.
So, good afternoon, everyone. Am I audible?
Yes, sir, you are audible.
Thank you, ma'am. Everyone, and thank you so much for giving me opportunity to present the paper. My name is Ashok Kumar Seni, and my paper title is Citrus Fruit Leaves Disease Detection and Classification with Optimized Deep CNN. I am presenting with along with my co-author, Dr. Rohit Bhatnagar and Dr. Devesh Srivastav. And sir, I belong to Jaipur, Rajasthan, and India. So these are the outline of my presentation. Objective, abstract, related work and research here, problem statement, proposed research methodology, software hardware requirement, experimental result, conclusion, and future work and references. So the objective first, the objective is to diagnose citrus disease at a lesser cost using deep CNN method. And second, to analyze performance of different optimization techniques. And third, to analyze challenges of different optimizers. So the abstract, and in agriculture, we know that plant disease are the primarily responsible for the reduction of the production and which cause the lossage of economy. And in plants, citrus is the major source of vitamin C and many nutrients, and it is used throughout the world. So there are many diseases. These are affected the citrus production. Disease are like anthracnose, melanose, scab, greening. So many diseases are there. These diseases reduce the production. So it is the urgent requirement to identify and classify the disease. So at the proper time or at the early stage of the disease, we can treat the disease, and so the losses can be minimized. So in this paper, I have used deep convolutional neural network model because in the last decade, due to the advancement of machine learning, deep learning, and convolutional neural network, these approach or these technologies are used for identifying and diagnose the disease in agriculture also. So I have used deep CNN. The major challenges is using the CNN to improve the performance and improve the training accuracy. So in this paper, I used several optimizing parameters and try to find out which optimizing parameters are best and which optimizing techniques is best. So for this, the related work, many models have been suggested which are used machine learning technique or machine learning models have been proposed. In these model, majorly are trained on the minimum or less number of images data set. So these models are not robust. Like when we try to predict the model, then they are giving the less accuracy, like in the reference number one, 87% to 87.26%. Some other models have also used deep learning techniques, but if the data set is large, then deep learning models provide more accuracy. But some models which are trained are the use like standard data set, like plant physics data set. So these are not appropriate for the multitasking purpose. So on the basis of those problems, I have used here the uh, neural network. So the proposed model, we have used input data set, and input data set both have images as well as fruits as well as leaf images, and these are subjected to the preprocessing. Different techniques I have used, like data augmentation, image scaling, because the images are in different shape and size, so preprocessing is required, as well as image labeling is also required. Then our neural network, after that, for the optimization purpose, we have used different optimization technique, and optimizers like Adam, RMS prop, SGD. Then on the basis of different performance metrics, I have conclude that this model is best and this have some deficiency. Hardware and software requirement are general, like Core i7 processor, 8 GB RAM, 300 GB hard disk, 2 GB graphic card, and Windows 10. I have used Python 3.7, and along with different Python libraries like TensorFlow, Scikit-learn, Keras, NumPy, Matplotlib. So when we're talking about the deep CNN, then deep CNN is always not accurate, because when we make our neural network deep, then the performance is degrade, or you can say speed is degrade. So there are various parameters for improving the performance as well as improving the accuracy, like batch normalization activation function, and one more parameter is the optimizer. So we try to find out the parameters. On those parameters, if we give the input, then there will be the minimum loss. Means the difference between the predicted value as well as the actual value will be less. So one important parameter is the optimizers. So one first is SGD, second RMS prop, and third is Adam. So if we're talking about the basic gradient descent optimizers, so this follow the updation rule, means weight is updated like WT equal to WT minus 1 minus learning rate multiplied by gradient. So there are three variations of the gradient descent, like batch gradient descent, stochastic gradient descent, and mini batch gradient descent. These are variation according to the data points, how they are updated their weights. So if we taking about the example, let's say we have a data set of 500 reports. So, and if we are using batch normalization or batch gradient descent, then the weight will be updated after 500 reports. If we have 10 epochs, then 10 times weight will be update. But in the case of SGD, means stochastic gradient descent, the weights are updated after each and every data point. Let's say there are 500 records and 10 epochs, then 5,000 times the weights will be updated. But in the case of mini batch gradient descent, the data set is divided into mini batch, like 500 records are divided into 100 batches. Then batches will be there, and suppose 10 epoch there, so 50 times the weight will be updated. So in the gradient descent, we try to find out the minima. So at the bottom we can see this is the minima, and we try to reach at this position. So in the gradient descent, as learning rate is updated, and as we reach at the bottom, then learning the updation becomes very low. So the convergence becomes very slow. So the speed is the major concern in this method, in this optimization technique. Second problem with this technique is the local minima. Minima sometimes our model will stuck in some local minima. rather global minima, because global minima is our optimal solution. But due to less updation of the weight, this can't reach at the global minima. So we have to satisfy at the local minima rather to the global minima. So this is the problem. Sometimes the saddle point is the problem with this algorithm. Like at the multi-dimensional graph, at the one side the weight is reduced and at the other side weight is increased. So it ultimately the resultant is zero. So weight will not update. So this is the problem with this technique. So another optimization technique, that is the RMS prop. In the RMS prop, we have used here momentum as well as we have updated the VT. VT we have updated by the adding of the all the previous gradient. So by this method we have achieved the VT. So this RMS prop is the improved version of the ADA grade. In the ADA grade, this is the summation of all the gradients. Because of this gradients, VT value becomes larger and VET is the denominator. So this part becomes larger. So the weight updation again becomes challenge. So RMS prop update this term by the beta VT minus 1 plus 1 minus beta del VT del WT whole square. So by this calculation or this mathematical formulation, VT becomes less value and VT goes at the denominator. So ultimately, this WT plus 1 value will be updated because of VT less value. So this is the solution in RMS prop. And third optimizer is the Adam optimizer. And Adam optimizer take all the best feature of other optimizers like velocity, momentum, as well as VT value. So both using the combination of both the parameters, this Adam optimizers becomes more efficient as compared to previous optimizers, and we are able to find the global minima. Adam optimizer able to reach at the global minimum. So I have used this data set. Different disease have different number of images. I have used here augmentation. After augmentation, getting the image like 16,506 images. And similarly, I have used here citrus leaves images as well as fruits images. So leaves images are 4,263 after augmentation. The layered architecture, different layers are in this model, like convolutional layer, activation function, pulling layer, fully connected layer, and output layer. So convolutional layer is used for convolute the input image, and it reduce the size of the feature map. Activation function for the non-linearity of the model. Pooling layer, this again reduce the size of the model, and pooling layer is responsible for the uh, for the for the like maintaining the overfitting or prevent the overfitting. Fully connected layer, this is the last layer, and this is connected by the output layer. Output layer have activation function like softmax function, because this is multi-class classification. So there are 7 classes which are classified by the softmax function. So after processing, this is the experimental result, and I have divided the data set into two part, 60-40 as well as 80-20 for finding the better accuracy. So in the first case, 60-40, Adam provided the accuracy 96.6%, whereas in the case of 80-20, the Adam achieve accuracy 98.6%. So this is the maximum accuracy. Other optimizers have less accuracy, like SGD have 95.6 and RMS prop have 93.7%. In the case of the splitting of the data set 60-40, SGD getting 93.6 and RMS prop getting 91.1%. So similarly, other parameter also taken: precision, sensitivity, specificity, F score. So Adam provide the better accuracy. This is the graphical representation of the result. This is another optimizer performance of splitting data. on the citrus leaves data set. So this is the result of the leaves data set. In the leaves data set, Adam getting accuracy of 95.3%, and the split of data 80 ratio 20, Adam getting 96.6%. So this is the performance of Adam optimizer. Similarly, SGD have 92.6%. RMS prop have 90.1%. In the case of 80 ratio 20, SGD getting 93.2% and RMS prop getting 90.7%. So this is the visual representation. Now conclusion, the suggested AI-based deep CNN model is tested with several optimization techniques, ADAM, SGD, RMS prop, and its performance is assessed using a variety of performance graphs such as accuracy, precision, sensitivity, specificity, and F1 score. ADAM optimizer achieved the best accuracy with 98.6% with 80 to 20 split ratio, while other performance measures like precision, sensitivity, specificity, and F score are 97.3, 97.5, 97.1, and 97.9%. The accuracy of SGD and RMS props are 93.2% and 90.7% respectively. So the future work, there are some shortcomings in the optimizers, so we can improve those shortcomings. Thank you so much.
Thank you, sir. We'll be moving on with questions.
Yes. May I know that from where you have taken your data set for your experiment, sir?
Ma'am, this is a online repository. That is standardized repository from where I collect the data set, and that is Kaggle.
Okay, so did you apply some pre-processing tasks as well?
Yes, ma'am. Yes, ma'am. I have data resizing because images are in different shape and size, and actually the enhancement of the images, because some images are blurred, as well as data augmentation. In the data augmentation, I have applied scaling, rotation, flipping. So getting by this model is getting more robust.
And how did you come up with those optimizers? Have you carried out some research regarding that?
Yes, ma'am. I have used because in nowadays maximum models are used Adam optimizer, but there are some deficiency also there. So I try to use different optimizers on the same data set and try to find out the comparison between actually,
Yes.
because some deficiency are there in each and every optimizer. We can't say that this optimizer is 100% correct and this one is have some deficiency.
Okay, and which tool you have used for your experiment?
Ma'am, I have used Python for this Python language, and like Google Colab I have used for this.
Okay, thank you.
Thank you, ma'am.
Thank you, Ashok. I have just two questions. Have you tried with it for the base model, deep learning base model? Have you compared with your data?
Yes, sir. I have used CNN model, and in the CNN I have used KNN model also there. But when we increase the layered architecture, or when we are making the deep CNN, then we are getting better accuracy.
No, I mean that there is RSNet, DenseNet, VDD16. Have you tried with this base model?
No, sir. I have not used these one.
Then you can your benchmark will be more stable if you want. I think you can think in future like this to compare with the base model also.
Yes, sir. I will do surely, sir.
Okay, thank you.
Thank you, sir.
Thank you, sir. We'll be moving on
Thank
with
you,
the
ma'am.
next presentation. I'd like to invite our next presenter, Subhashi Sain to present the paper titled Design and Development of Low-Cost Multifunctional Wheelchair with Patient Monitoring and Obstacle Detection. Please go ahead, sir.
Okay, thank you. Am I audible to everyone?
Yes, sir.
Okay. A very warm welcome to our slide. I'm Subhashishan from East Delta University. Our paper ID is 3, and the name of our paper is Design and Development of a low-cost multifunctional wheelchair with patient monitoring and obstacle detection system. If we go forward, that the outline of our slide will be objectives, introduction, block diagram, methodology, implementation and results, conclusion, and references. The objective of the project is to develop a low-cost prototype of a wheelchair with several characteristics that can be used by the ill and the disabled. In the paper, a low-cost multifunctional wheelchair with patient monitoring system and obstacle detection is proposed. The multi-purpose wheelchair is built with the characteristics required to granted safety and easier to use. In general, we can say a disabled person needs assistance for self-movement. The objective of the project is to develop a low-cost prototype of a wheelchair with several characteristics that can be used. Okay, the user friendliness. Okay. The user friendliness of the multi-feature wheelchair is being improved through the lessons and strained on the patient attendance. Every individual who is ill or disabled will feel more confident as a result of being independent. One of the most common tools used to help disabled person with their mobility. So the mobility of wheelchair, according to WHO, World Health Organization, almost wheelchair is required for 15% of the world population, which is over 1 million individuals. A wheelchair is the most user seats in its mobility aid. The many physical disabled person who can satisfy with motorized wheelchair to meet their needs. Some members of the handicapped population finds using the typical motorized wheelchair difficult or impossible. So to design such kind of multi-feature wheelchair which electrically and energized with of this research, in the wheelchair a joystick will be used. We'll see further in our next slide. So if we move the block diagram of our paper, then the main heart of our project is a microcontroller. Then the microcontroller will be powered by a power supply unit, which will be we are using 12 volt 8 amps battery to drive the wheelchair. And for the changing the DC battery, for the charging of the DC battery using a solar system of 12 volt and 18 watts. 18 watt. Then a voltage regulator IC will constantly supply 5 volt, which we'll use for the circuit, and that using wheelchair. And for a better movement, we are using motor which will control by L293D motor controller, and we are using some sort of medical component like blood pressure measurement and ECG facilities. And for those persons who will use this chair, it might be bad for them that some sort of smoking person or alcohol person come to them. So we are using a smoke sensor and gas sensor and alcohol sensor for preventing those persons to come to this patient. And for in forwarding, the block diagram details, the paper design and concept are explained via block diagram, which we've seen before. The necessary part and working circumstance of the design are shown in the block diagram. The proposed plan to develop an electrical power wheelchair. This wheelchair has joystick for movement and an ultrasonic sensor while the patient is or the user is moving that wheelchair. If some sort of obstacle in front of them or in front of the wheelchair, then it will show a message to that user that an LED will indicate that something in front of that wheelchair or beside of the wheelchair. The main component of this wheelchair is a temperature sensor and a heart rate sensor. The patient will see the heartbeat rate of him or her while using this machine or this wheelchair. DC motors that are infrared to the microcontroller. We are using 8 mega series of microcontroller by the using motor driver response of the signal obtained by the ultrasonic sensor controlled by the wheelchair detection. If we move forward, there is a pulse sensor which will show the pulse rate of the user by using an LCD display. That LCD display will show 16:2 variable. Then the LCD display will control by an Arduino, which is microcontroller basically. Then the diagram of the ECG sensor, that also controlled by Arduino Nano and microcontroller. The model of the ECG sensor is AD8232. We are using AD8232 for showing that ECG sensor. Then moving forward to the diagram of the temperature sensor, we are using the temperature sensor for showing the temperature value. It might be a patient or anyone else who are using this chair or this wheelchair. At the same time, if he's ill, that person or that user can see the temperature value of his body. And again, we are using same LCD 18:2 display, and by using an Arduino Nano. The working procedure of the chair is the flowing chart showing here, and the main goal of the study is to assist impaired people in using wheelchair with several functions. The information model is the multifunction wheelchair design created by using our system microcontrollers and 8 mega. All of the sensors which are mounted on the multifunction wheelchair provide inputs. These sensors provide output and let the user choose and reduce the optimum options for the multi-feature wheelchair for safely movement. The flowchart description is here, and beside this, there is a few features of the wheelchair. We will use two actuators that will be able to convert the wheelchair to bed and bed to wheelchair. It will be one of the major and effective feature for our multi-feature wheelchair. There is a smoke and a gas detector which can detect gas and smoke visible around of the wheelchair. It will also able to detect alcohol. These two features act like a protective environment for the user. Here is the data chart of our testing results, and the sensor temperature and the monitor temperature is showing here. And for moving forward, the results which we tested by checking some patients, the data is here, which is blood pressure measurement and sensor pulse. And here's the human body. We have set up the sensor of a human body, and here's the result. And the data of the ECG is almost similar to a real ECG function. We are using an ECG sensor, and here's the graphing plot which we have got from Excel file. And here's the model view. We have built this wheelchair in really. Here's the actuator mounting, which can convert this and this leg rest side into bed like this, and an ultrasonic sensor mounted in the top of the head, and an ultrasonic sensor is mounted in the top of the leg. This ultrasonic sensor will allow to movement of this actuator, and it will indicate an alarm, while the sitting part will be will be in some sort of obstacle. And then smoke sensor and alcohol sensor, we have mounted these types of sensors in besides of the patients head and basically specifically the sort of nose that will give a relaxation of that user. So here's the key of the actuators and joysticks for movement and actuators key for moving the chair from converting the chair from chair to bed and bed to chair. So in conclusion, a system for steering an electric multi-feature wheelchair that is the both efficient and safe has been designed and tested. We have tested this design and we have built this design in real world. Okay, the multifunctional wheelchair, smart wheelchair, is a design that allows travel left, right, move backward, and remain in any place. However, by investigating new multi-feature wheelchair that are bulky and sophisticated design have been addressed. When the user needs to inform someone, we take care of the user is an emergency, or he or she, that person who is using that wheelchair, to do the effortlessly with the help of the buzzer. That is mounted on the multi-feature wheelchair. This wheelchair can be assembled a huge benefit for general population. The effort is entirely focused on achieving a social goal. And here is the references which we have used for making our project really helpful for a person who are really unable to move from place A to place B. And thank you everyone for watching our slide. If you have any question, please you can say this.
Yes, congratulations. Very well presented. No questions from my side.
Thank you, ma'am.
Dear Subhashi, thank you for your nice presentation. Can you please tell us what is the key challenge for your monitoring system here? What key obstacle you find?
I have found that the ECG part, that we did not get any permission to test that ECG, which is really happened in any hospitals, just because of some obstacles. We have tested that ECG part from a small sensor. So that was one of the obstacles. And another obstacles was that while we are building that our wheelchair, the actuators was not available in the market. We have built that actuator by mechanically, by using some sort of nut and bolts, and we have built that actuator by using our some of our friends' workshop, basically mechanical workshop.
What is the present cost of this type of wheelchair, and what is your proposed cost?
Sir, we have built this wheelchair from starting of our bachelor course. So we built and we got failed, and so the approximate cost of this wheelchair around 30,000 BDT, Bangladeshi taka, 30,000. It approximately 30,000 to 40,000 Bangladeshi taka.
It's your cost or current market cost?
Sir, these types of wheelchair are not available in the market right now. We have researched that types of wheelchair which can give relaxation to patients or users, such kind of temperature measurement, ECG measurements, and some smoking relaxation or alcohol relaxation. So we built this wheelchair in 30,000 to 35,000 Bangladeshi taka. That is our cost, not a commercial cost.
Okay, thank you.
Thank you, sir.
Thank you, sir. We'll be moving on with our next presentation. I'd like to invite Zlatinka to present the paper titled Distribution and Statistical Characteristics of a Small UAV Audio Signal. Please go ahead, ma'am.
Good afternoon, everybody. Do you see my screen?
Yes, ma'am, it's visible?
Recently, unmanned aerial vehicles are widely applied for many purposes in the real world. This article discusses the sound radiation of an unmanned aerial vehicle on the example of a small vehicle platform called Phantom 4. Unmanned aerial vehicles are capable of performing a wide range of useful functions and have recently become an integral part of any modern army. They are capable of performing a wide range of military tasks, from reconnaissance to the destruction of enemy forces and assets. One of the biggest advantages of a small UAV is the possibility of long-term stay in the combat zone, providing the user with video streams in almost real time. But they are much cheaper to produce and operate compared to manned vehicles. The main difference between UAVs and other air targets is their low radar visibility because of their small size. The use of appropriate materials and technologies in the production process that weakly reflects radio waves, low altitude and flight speed. At the same time, the flights are accomplished by sound radiation. Thus, the detection of UAVs using an acoustic channel is very relevant. I will pay your attention on the characteristics of the sound radiation of a small UAV on the base of this model, Phantom 4. The movement of the UAV is accompanied by electromagnetic and acoustic radiation, so the choice of method of detection, registration, and tracking is determined by the characteristics of each type of radiation. Experimental studies have shown that the signal-to-noise ratio created by electromagnetic sources of UAVs has a fairly low value. Therefore, when choosing a radiation source, preference is given to the acoustic field created by the propulsion system of apparatus. The total spectrum of acoustic radiation of the UAV is due to the harmonic components of the engine radiation, the noise of the propeller revolutions, the radiation of a mechanical nature, as well as high frequency and low frequency components of the engine noise with frequency bands. The total spectrum of acoustic radiation of the UAV is due to the harmonic components of the engine radiation, the noise of the propeller revolutions, the radiation of a mechanical nature, as well as high frequency and low frequency components of the engine noise with continuous frequency bands. The mathematical model of the acoustic radiation in the absence of noise can be presented by the following formula, where M is the number of harmonics of acoustic radiation, N is the number of propeller plates, and AM, VM, and FM are respectively the amplitude, the initial phase, and the frequency of the nth harmonic. Here you can see a photo of this model of small UAV, Phantom 4, which is an object of our investigation. The quadcopter Phantom 4 is designed to perform civilian goals and objectives. It has a very large functionality. The main purpose of this UAV is observation flights and aerial photography of the terrain. But also it can be applied for environmental monitoring, control of traffic flows, organization of security, etc. On this figure, you can see time realization of the quadcopter's audio signal. And on the next figure, we can see the amplitude spectrum of audio signal. As we see, the maximums are at frequencies of 86.4, 166.1, 345.6, etc., as it is shown. On figure 3, we can see the windowed Fourier transform time realization of the quadcopter's audio signal. Window's Fourier transform shows the dynamics of changing the frequency of the signal over time. This figure actually demonstrates the non-stationarity of the acoustic signal. It is also possible to observe how the rotation frequency of the screw and the harmonic change. Second, fourth, and sixth harmonics have powerful values, but their values are not constant. We determined also distributive laws of instantaneous values of the quadcopter audio signal. For random processes, along with the spectral correlation representation, it is important to know the distribution of instantaneous values. This allows to estimate in particular the dynamic range of the processing device and build a schematic diagram of the device. In addition, knowledge of the density of the signal distribution allows to build an adequate mathematical model and a signal processing model. Thus, the distribution density allows to solve both the problem of software implementation and hardware implementation. We evaluate the law of distribution of instantaneous values of the audio signal and examine the audio signal in 3 time periods. Here is an example of histogram of time realization of the quadcop's audio signal and its approximation by various distribution laws. On the next table, we can see the results of estimated parameters of the temporary implementation of the quadcopter audio signal. In the next table, we present the probability density formulas which we used for calculating the theoretical distribution parameters. And in this table, you can see the calculated theoretical distribution parameters for the 3 time periods, 1, 2, 3, and using the following distributions. We used probability density formulas I already showed, and using the Kolmogorov's criterion, there is a maximum deviation between the sample f star of x and theoretical f of x integral distribution functions. For a suitable distribution, the critical value, or also called significance value, can be calculated by the following formula. Therefore, we have to check according to the Kolmogorov criterion with all the distributions and choose the one for which the level of significance is maximum. Using Kolmogorov's consent criterion, we obtained that the closest lower distribution of the considered realizations is the student's distribution. And the critical significance level in this case is 0.000071. The graph of the density of the student's distribution as well as the normal distribution is symmetrical and has a form of a bell, but with heavier tails. That is, realizations of a random variable having students' distributions tend to differ more strongly from the mathematical expectation. Students' distribution presents a family of curves on the base of the degrees of freedom, which is related to the sample size. With increasing of the sample size, students' distribution approaches the normal distribution. As a conclusion, I can say that since the signal to noise ratio generated by the electromagnetic sources of unmanned area vehicles has a very low value, the task of receiving and processing audio signals is relevant. 3 realizations of the sound radiation of the Phantom 4 lasting about 1 second are considered. The spectra of the considered realizations contain the rotation frequency of the screw in the region of 80 Hz and its even harmonics, in particular the second, fourth, sixth, and eighth. The law of distribution of instantaneous values of sound radiation is evaluated. On the basis of the Kolmogorov's criterion, it is obtained that the most reliable considered realizations are described by the student's distribution. All results in this paper are for the model Phantom 4. The parameters of the UAV's sound emission are important as they allow detection of the UAV as opposed to its electromagnetic emission. The technique discussed in the article can be applied in the future to other UAV models, the amplitude, time, and frequency parameters of which may differ significantly from those considered here. The research perspective is to detect specific types of UAVs. I can show some references here. Thank you very much for your attention.
Thank you, ma'am. We'll be moving ahead with the questions.
Yes, very well presented, ma'am. There is no question from my side.
So, Amrita, would you like to ask any question? Thank you, ma'am. Sritinka, we'll be moving on with the next presentation. I'd like to invite Alexander to present the paper titled Improvement of Approaches to Intangible Assets Valuation. Please go ahead, sir. I think we do not have. We do not have, sir. We'll wait for a moment and then we'll be moving on to the next. I'd like to invite presenter Niharika Gauri to present her paper titled Parametric Comparison of Deep Learning Models for Musculoskeletal Abnormality Detection. Please go ahead, ma'am.
Hi, can you share my screen?
Yes, you can.
Thank you. Okay. Hello everyone, I'm Niharika Gauri from WS University, and I'm going to be presenting on behalf of my team today. Our paper is titled Parametric Comparison of Deep Learning Models for Musculoskeletal Abnormality Detection. In this presentation, I will be going over the motivation behind this paper and briefly go over the dataset and deep learning architectures. I will then present our results and conclusions from the implementation. Musculoskeletal disorders are conditions that affect joints, bones, muscles, and the spine. The aim of this paper was to investigate the use of artificial intelligence, deep learning, in particular to assist radiologists in the preliminary screening of radiographs. The motivation behind automating the preliminary screening is to help reduce radiologist workload. As we all know, deep learning and computer vision enables computers to derive meaning from digital images. To determine whether a given X-ray is normal or abnormal, we have implemented architectures such as custom CNN, ResNet, VGG, DenseNet, and others. This study provides a comprehensive comparison of all the techniques that can be implemented to enhance the performance of existing models. These techniques include pre-processing the dataset, augmenting the dataset, as well as using ensemble techniques to combine models. So the dataset is a very crucial part of any machine learning model. The dataset that we have trained and tested our models on is the Mura dataset. It is an open source dataset curated by the Stanford ML group. It consists of over 36,000 image samples in the training set and around 3,000 image samples in the validation set, all of which are monochrome images of X-rays. The dataset consists of subdirectories referring to different parts of the body, such as elbow, finger, shoulder, and so on. And each subdirectory consists of labeled abnormal or normal studies. A detailed literature survey has pinpointed poorer performance of machine learning models on the radiograph images of the upper extremities. Therefore, in this paper, we focus on classifying abnormal shoulder radiographs. The dataset for shoulder contains around 8,000 training images and 500 validation images. Pre-processing. The first step to improve the performance of any machine learning model is to improve the quality of the training dataset. Analysis of the X-rays established that the images were of low brightness and low contrast. The features that the CNNs are required to focus on and learn from are the abnormalities present in the bone structure. In order to combat this problem of low brightness and contrast, we experimented with histogram equalization and contrast-limited adaptive histogram equalization, CLAHE for short. So the images that you see to your right over here, these are examples of how the image appeared before pre-processing and after pre-processing, after the use of CLAHE. As you can see that the bones are more clearly visible in the pre-processed image. Another technique employed was unsharp masking. This technique helped to enhance the bone structure, thereby improving the visibility of any abnormalities. Histogram equalization ended up producing noisy images. Therefore, we used filtering techniques such as median, Gaussian, and Wiener filtering to smooth the noise produced. Figure A depicts a radiograph before and after unsharp masking. You will be able to notice that the structure of the bone is a lot more cleanly visible after the pre-processing. Figures B and C depict the before and after of median filtering and Wiener filtering. Data augmentation. So this is a technique used to increase the size of the training dataset by applying transformations such as flipping, changing brightness, rotating, etc. We initially augmented our dataset using the Python library Albumentations, but we subsequently switched over to using image data generator, which is an inbuilt class of Keras. We used this to create an image pre-processing and augmenting pipeline that allows image samples to flow through and pass directly to the CNN models. The parameters that we used to evaluate the pre-processing methods employed are PSNR, that is peak signal to noise ratio, mean square error, and NIQE and BRISQUE scores. We will now move on to the deep learning models that we have implemented. Just to recap, deep learning is a wide area within machine learning that includes neural network architectures such as CNNs. The reason that CNNs excel at processing images is due to their ability to perform convolution operations and use pooling layers to reduce the dimensions of the images while learning the features within the image. In the context of this particular application, the CNN models use features such as fractures in the shoulder joint, etc., as abnormal features or anomalies. For this application, we started with a very fundamental custom 4-layer CNN to get a lay of the land, which consisted of 4 convolution layers, max pooling, and ReLU activation. It demonstrated a testing accuracy of 65.3%. We subsequently moved on to using VGG16, VGG19, ResNet 152, ResNet 50, and DenseNet 201 to leverage the advantages of transfer learning. VGG, ResNet, and DenseNet are all models that have been pre-trained on the ImageNet dataset. We also implemented models such as MobileNet and Inception v3. Evaluation parameters. So the parameters that we use to evaluate the deep learning models are Cohen's-Kappa score, accuracy, area under the ROC curve, and F1 score. Ensemble techniques. The aim behind merging the predictions of different individual models through an ensemble technique is to use the strengths of certain models to make up for the deficiencies of others. This improves the stability of the overall model. We have implemented 3 ensemble techniques, which are averaging, weighted averaging, and stacking. Averaging takes the predictions of the best performing models and averages it to produce a final prediction. Weighted averaging is similar to averaging, but in this technique, we assign higher weights to better performing models, making sure that, that it contributes more to the final inference. We used a grid search algorithm to find the optimal combination of weights assigned to individual models, with DenseNet having the highest weight. I will now be presenting the results of the implementations. Pre-processing results. According to our analysis, we concluded that this was the order for the PSNR and this was the order for the MSE. Mura images tend to be impacted more by insufficient contrast rather than noise. Hence, Clahe and unsharp masking is the optimal pre-processing method for this particular use case. Even though Wiener filter has the highest PSNR and the lowest MSE, the images produced were unsuitable in this scenario due to excessive blurriness. Comparison of deep learning architectures with and without pre-processing. Before pre-processing, we trained the custom CNN model as well as the other architectures for 5 epochs and tested them to find the custom CNN had the least accuracy and DenseNet had the most. We then tested these models on the pre-processed dataset. As you can see in the table, the testing accuracy for both the models have improved. So on the left-hand side, we have accuracies before pre-processing, and on the right, we have after. Similarly for DenseNet. Since pre-processing improved the results for basic CNN and DenseNet, we implemented it on various models as depicted in this table. So we have VGG16, VGG19, ResNet 152, ResNet 50. And as you can see, Clahe and Unsharp have both performed similarly, and they have improved it from before pre-processing. For a span of 5 epochs, the architectures that delivered the highest performance for this application were VGG16 with 67%, VGG19 with 65%, ResNet v2 with 68, ResNet 50 with 66, DenseNet 201 with 76. Comparison of ensemble deep learning architectures. So we then used average ensemble technique to combine these top performing models that I mentioned in the previous slide in groups of 3 to note which combination is optimal. As the table depicts, the combination of VGG16, VGG19, and DenseNet gave us an accuracy of 77.3%. And this was for a span of 15 epochs. Here we have a simulation output. The figures display a simulation of classification of test shoulder radiographs from Mura being classified as positive, which means this is an abnormal radiograph, and negative, which means this is a normal radiograph. So these simulations have been created using Gradio API. So for pre-processing, we came to the conclusion that Clahe and unsharp masking perform the best. Out of all the individual models we tested, DenseNet 201 yielded the highest accuracy of 76.7%. The weighted average ensemble of VGG16, VGG19, and DenseNet 201 yielded the highest accuracy of 78.3%. And we did try the stacking ensemble technique, but it gave us lesser precision, which was around 61.3%. Future research areas include exploring ensemble models for more than 3 models, optimizing hyperparameters, and developing an application or website for ease of use. These are our references. This concludes my presentation. Thank you very much for your patient listening.
Thank you, Ma'am Niharika. We'll be proceeding with the questions. Any questions, anyone?
Yes, Niharika, I have one question. That
Yes.
How did you come up with the idea that you should use that CNN model for your image classification process? Like there are many other models are available. So how did you come up with that solution?
So we initially did a lot of literature survey, and we found a couple of papers all regarding musculoskeletal classification itself, and most of them have like used CNN models itself. And
so actually, in that case, you should have used those papers in your presentation as well. Those base research papers.
Yeah, that makes sense. So the Mura dataset was introduced by the Stanford ML group, and they have this paper. And they initially used DenseNet as well to classify all of these. So they classified everything, and we just focused upon the shoulders because their conclusion was that it wasn't performing as well for the upper extremities of the body.
And one more suggestion that you have used the papers of year 2018 and so.
Yes.
So actually the wide variety of research have been carried out in this area. So you are suggested to use the latest paper, study latest papers.
Okay, yeah, for sure. Thank you.
So
I have just one question.
Okay.
Yeah.
What is the size of your data set in this research?
So for shoulder, we had around 8,000 images to train it upon. One moment, I'll just show you. So we had the entire data set consisted of over 36,000 images for training and 3,000 for testing. But since we focused on the shoulder, we had around 8,000 images, 8,379.
Okay, thank you.
Thank you.
Thank you, Ma'am Niharika. Since we are over with the presentation, I'd once again like to call Sir Alexander. If you're present, please come up. It seems we do not have him. That brings us to the ending of our presentation. I sincerely thank our authors for their excellent presentation contribution in this session and all our participants for being a part of this international conference. I hope this session was informative enough, and we, on behalf of the whole team, thank you for the support during this 7th conference version and all the previous 6 versions of the conference. We will be happy to have you in the 8th version in 2024. All the presenters will be getting their digital certificates through email within 2 working days. Furthermore, all the papers have been already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of WS4 2023. I also thank our session chairs, Dr. M. Firoz Mridha and Ma'am Monica Rathod for chairing this session, a token of appreciation to the chair on behalf of Team World S4 2023 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, sir and ma'am.
Yes, thank you so much to all our presenters for the illuminating presentations and discussions. Thank you so much.
Thank you, ma'am. I kindly request all of you to turn on your camera for a quick snapshot of the virtual conference. Please turn on your cameras. Thank you, everyone. Stay safe and take care.
Thank you.
Thank you.
Thank you, ma'am.
Thank you.
Thank you.